Welcome back, students. So in today's class we are going to see about the capacitor. See, capacitor and inductor both are energy storing elements, but in which domain they are storing the energy is the matter. I have already told that. So see here, capacitor stores the energy in electric field. See, here capacitor is what? It is nothing but two parallel plates. So in between these two parallel plates, there would be some dielectric. The dielectric might be of paper, mica, otherwise of air, any material it would be. Okay. So the capacitance depends upon the permittivity. We can also say that the permittivity of that particular dielectric in between these two parallel plates. So capacitor means we want to consider the voltage. Okay, so see here I am taking the voltage. So how can I write the current for the capacitor? Current for the capacitor is equal to capacitance into rate of change of voltage, because for the capacitor we are going to consider the voltage, and in the previous class we have seen about what inductor. So inductor, what we considered? Yes, rate of change of current. For inductor, the prime is current, and for the capacitor the prime is voltage. Okay, so see here, how can I write the current for the capacitor? Current I is equal to C, rate of change of voltage. Okay, so how can I write the dV? So dV is equal to 1 divided by C, because I am taking the capacitance here and I am cross multiplying this. Okay, so 1 divided by C, I and dt. So what is the value of V? So I want to integrate on both sides. So integration of dV is equal to 1 divided by C is constant. Capacitance value is constant. I dt. Time, depending upon the time, it's varying. So 0 to t, here also 0 to t. If I am differentiating dV, what I will get? Here I am differentiating means what I will get. So V, upper limit is t and the lower limit is 0. So V of t minus V of 0 is equal to 1 divided by C integration of 0 to t I dt. And for V of t, I am going to take this value there. So 1 divided by C, 0 to t I dt plus V of 0. Here V of 0 is nothing but initial voltage. Initial voltage. And one more point I want to tell you, that capacitance also we can write capacitor as charge per voltage. Charge per voltage. And the unit of the capacitor is what? Farad. The unit of the inductor is what? Henry. Okay, the unit of the capacitor is farad. So see here, this is the voltage for capacitor. Voltage for capacitor. So what is the formula for power? We all know power P is equal to V into I. We already have wrote the I value here. So we are going to substitute this I value here in this equation. So what is the value of power P is equal to? Power P is equal to V into C dV divided by dt. Okay, so what we will get? The power is V into C dV by dt. And similar to that, we want to consider the energy. So energy, what is the formula for energy? Energy W, otherwise E is equal to, we can write power into time taken. Power into time taken is nothing but energy. We can also represent the energy as energy stored in the capacitor as W. So W is equal to dW. We want to consider here dW means here also we want to take dt. Okay, so what I want to do to calculate W, I want to integrate on both sides. So here differentiation and integration get cancelled. Here differentiation and integration get cancelled. So W is equal to integration of what? V into C dV by dt into dt. Okay, so this dt get cancelled and the capacitor value is constant. So take it out from the integration of V dV. So what we will get if I am integrating V, which is variable dV. See here, the V is variable because here I am putting dV. So V squared by 2, C into V squared by 2. How I can write this? 1 divided by 2, C Sorry. How we can write this? How we can write this? 1 by 2 C V squared. That is energy is equal to 1 by 2 C V squared. Clear? So this is the formula for energy stored in the capacitor. See here the capacitor. Capacitor, the prime is voltage. So energy stored in the capacitor is nothing but how we can write 1 by 2 CV squared. For the inductance means how you can write 1 by 2 L, inductor L. There the prime is current Li squared. See here, it is there. How I am writing here? W is equal to 1 by 2 Li squared. But here for capacitor I am writing W is equal to 1 by 2 CV squared. So let me consolidate all those things what we have seen so far. So what first one, capacitor is energy storing element, but in which domain? Yes, electric field. Capacitor stores energy in electric field. So see here, if I am giving the voltage, if there is some voltage between the capacitor, that particular voltage is nothing but constant voltage. What is meant by constant voltage? AC voltage, otherwise DC voltage. The voltage constant means it is a DC voltage. If DC voltage means what will happen to the current? DC voltage means what will happen? dV by dt is, yes, rate of change of voltage with respect to time. Here in DC it does not vary depending upon the time because it's a constant value. AC only it varies depending upon the time. So for DC voltage, if I am giving across the capacitor means constant, I am differentiating means what would be the answer? Yes, 0. So 0. If the voltage 0 means, then what about the current? Current I is equal to dV by dt. If dV by dt is 0 means, if dV by dt is 0 means current is also 0. Yes. So current 0 means capacitor acts as what? Open circuit. Open circuit. If voltage 0 means short circuit. Current 0 means open circuit. So the capacitor acts as open circuit. Capacitor acts as open circuit. Even though the capacitor acts as open circuit, it stores the energy. Yes, it stores the energy because see the formula for the energy stored in the capacitor. W is equal to what? 1 by 2 C V square. Whether it's depend upon the current? No. So why worry about the current 0 and becoming the capacitor open circuit? Even though the capacitor is open circuit, it stores some energy because the energy stored in the capacitor does not depends upon the current. It depends upon the voltage only. So even though open circuit capacitor stores energy. Even though open circuited. That's all about capacitor. And one more thing, if the rate of change of voltage with respect to time is very high, that is for 0 second the voltage changes from 10 volt to 100 volt, means what happened? For the very small time means I consider just 0 second, okay, 0 second, otherwise 1 second. Anything divided by 0 is infinity. What will happen to the current? It rises abruptly. Current rises abruptly, but practically it's not possible. For the change in time, the voltage increases gradually, otherwise decreases. What discharging means? Decreases gradually, okay, gradual rise, otherwise gradual decrease in the voltage. So here all the unit of the capacitor is farads. Thank you students. Please share with your friends, and if you like the video means please comment with that video, and if you are having any queries means please don't hesitate to ask me. You just ask the question in the chat box. Let me answer a question in the next video. Thank you very much for watching. Thank you students.